So in our last video, we learned about standard form. And I want to show you now a situation where you can apply it to the problem we started working with on Friday. So this was not really anybody's specific problem, but this is just a sample one that I made up, so you can try to use this to relate it to the one that I'm going to ask you to solve for your assignment today. So the first thing I want you to recognize is when we look at a problem where we don't know the answer to the problem, we first need to figure out what it is that we don't know. And so in this case, our variables are those things that we don't know. So we're trying to figure out how many pieces of each candy there are. So I'm going to say, instead of saying x equals candy A, I'm going to say x equals the number of A candies. And similarly, we could say that y represents the number of B candies. Could you have switched those? Absolutely. I just chose to go alphabetical, so when I write my equations, it's easier for me to remember it. And so, pick your own method, but that's what I do. Okay, so with equations, I think, oh goodness, I can't remember which group did this on Friday, but one of them kind of set up like a strategy where they said, well, I knew that it was 2 cents for every A candy, so they said, okay, well, we just kind of like picked a number here. We multiplied it by 2 cents, and we knew that the other candy cost 1 cent, so we just picked another number that we could multiply to get our total cost. Okay, well, we're going to use that same format right here. And so one of our equations, we're just going to basically use this strategy that was brought up in class Friday. So I'm going to say 0.02x, because notice x represented the number of A candies. So your second clue says every piece of A candy costs 2 cents. Well, if I take 2 cents times 3, that means I spent 6 cents on 3 pieces of that kind of candy. All right, but there's not just one kind of candy. There's another kind. And so I'm going to call that candy Y. And together I know they cost 14 cents. All right, so if you're like me and a lot of you other people out there, you don't necessarily want to work with decimals. So something like this, an easy way to get rid of decimals is just to count how many places you need to move it to the right to get rid of your decimals. And in this case, 2 places. Well, if you multiply every term times 100, that will eliminate all those decimals. So I'm just going to multiply every term times 100. And our new equation will be 2x plus 1y equals 14. All right, and that one looks a little bit cleaner. Notice this is in standard form. And so here's a situation where standard form was a lot easier to work with because we didn't know just one slope. We knew 2 rates. We knew the total amount. So this is a perfect time for standard form. All right, now this last kind of goofy looking equation or goofy looking sentence is going to help us produce our second equation. Okay, and so as you read this, you can pretty much translate each of these symbols, each of these words into symbols. So 2 more than double B. Well, 2 more then would indicate to me that I'm adding 2 more than double the number of B. And if I do that, it says it will equal the number of A candies. So this is what I'm working with. Since I chose X's and Y's as my variable, I'm just going to look back over here and say, okay, well, instead of B, I can use the letter Y. And instead of A, I can use the letter X. And so now when I graph it, we have X's and Y's, which are, I think, a little bit easier to work with sometimes than like A's and B's. Okay, so these are my 2 equations. If you have a question, stop the video right now and ask a teacher to clarify. Otherwise, we're going to keep on keeping on. All right, now, 2 equations. I'm going to copy these guys down below. Oops. Maybe. Looks like it's going to make me take the whole thing. So let's start with this first one. All right, now, if we're going to arrange it so that it's in slope-intercept form, all that really means is get the y by itself. Because we want this to be y equals mx plus b. All right, well, we worked with these last week. The whole idea is to isolate this term by undoing what occurred to the y. So it looks like it was multiplied by 2 and then added 2. So we're going to do the inverse operation in inverse order. So I'm going to go minus 2 on each side. And so we get 2y equals x minus 2. And then to get y by itself, we're going to divide by 2 on both sides. And then here, so now y is by itself. All right, so we get y equals... Okay, this is the part you got to be a little careful on because let me just do this off to the side. If I said to you 8 minus 2 divided by 2, if I told you that was equal to 3, I think most of you would agree that 8 minus 2 is 6, divided by 2 is 3. Okay, now check this out. If I take my division and split it up, if I take 8 divided by 2, and apply the denominator to the 8, and then apply the denominator to the 2, we still get 4 minus 1, which is also 3. All right, that's pretty sweet, because over here, that means this 2, I can split it up so that it's x over 2 minus 2 over 2, which is the same as 1. All right, and just to kind of clean that up even a little further, I'm going to rewrite x over 2 as 1/2 x, because technically there's a 1 in front of my x. And that way I can see my slope is 1/2, and my y-intercept is -1. Okay, that's something we know how to work with. All right, so this guy right here, done. Let's take the second one down. And we're going to do the same thing. So pause the video, try it on your own, fast forward until I show the answer, see how you did. If you missed it, you'll have to go back and watch what I did. All right, so solve this one for y. Go ahead and pause the video now. All right, if you're watching this, that means either you didn't feel confident or we made a mistake. So just like before, I'm going to get rid of my other term first. So I'm going to subtract 2x. And so we get 1y, or y is equal to 14 minus 2x. I always put my x term first when I rewrite it, so that way it looks like y equals mx plus b. So my negative 2x can be the first term. Notice I kept the sign with my -2. 14's positive, so I'm going to put plus 14. All right, that, ladies and gentlemen, is probably the hardest part. Now that we got this done, just like with your position time graphs, we're going to graph these and just find out where they intersect at, and that's going to represent our solution. So I'm going to just draw in an x and y axes. The reason I left a little room down here is because I have a negative y-intercept. So let's see, looks like scaling by 1 should be okay because our largest y-intercept is 14. So if I go like 5, 10, and 15 here, we should be good. And let's see, let's just put a few other values in. 5. All right, let's see. I chose X to represent number of A candies. So I'm going to put that down below. And I chose Y to represent the number of B candies. So we'll put that going vertically. All right. So we got our graph set up other than our title. So this would be B candies versus A candies. For, I didn't finish it, but we could say for candy game or bag of candy. All right, now I'm going to color code so you can follow this easier. We have my first equation here. Has a y-intercept of -1, a slope of 1/2. So let's go to the y-axis. I'm going to go down to -1, which is what my y-intercept was, and then I'm going to do rise over run. So rise 1, run 2. And again, I'm assuming we're scaling by 1 here. So this would be like 5, 10. Okay, and so we're just rising 1, running 2. Repeat, repeat, repeat. I do this about as many times as I can fit on the graph, at least until I get my second line drawn. The more points I can add, I feel like the more precise my solution is going to be. All right, so draw your line of best fit. Since we used our slope, they should be pretty much right on the money there. All right, and so that guy, I told you I had color code, so I will. That line, the yellow equation, and the yellow line go together. All right, let's do the second one. The second one has a y-intercept of 14. So we're going to start up here at 14 on the y-axis. And the slope is -2, so that means I'm going down 2 for every 1 unit we move over. Down 2, run 1, down 2, run 1. Some of you like to put this actually like -2 over 1. That's fine. You can do that. It's your world. Rock it. Own it. All right, so we got our points here. Oh, check this out. There's our intersection point. So we can see if we did this right. All right, I'm going to draw the line. According to my graph, this solution point represents 6 of the A candies. So 6 A's. And let's check on the B candies over here. It looks like this would be 2 and 2 B candies. All right, so check out my clues. 6A, 2B. Okay, 2 cents for every A candy. So let's see, there were 6 of those and 2 of those. So let's see, 2 cents times 6 would be 12 cents. 1 cent times 2 would be 2 cents. Check that out, 14 cents. Right on the money. All right, now, it says if we double the amount of type B's and add 2 to it. So if I double this, 2 times 2 is 4. And then I add 2 more onto that. I'm supposed to get the same number of candies as the A's. Well, that definitely makes sense. So down here, just to confirm, if you double this number, which is 4, and add 2, we're supposed to get the number of A candies. And we can see here that we just found our solution graphically, which means, and then we checked it up here algebraically. Everything checked out, so we figured it out. Good job. Your job is to repeat the same process I did. Get your variables, write your equations and graph. These 3 steps I just did. I'll even number them. Do this step, do this step, and do this step. All 3 of those things is your responsibility for the candy problem that you received. Let me know if you have any questions.